Our topic today is writing solutions to compound inequalities. Your learning target is I can solve a compound inequality and apply it to real world situations. Please get this topic and this target as well as today's date in your notebook. Now, before I spend too much time getting into compound inequalities, I want to spend a little bit of time on this idea. If you're an in-person student and anytime you need help or you don't think you're understanding, raise your hand and ask for help. You have one or two teachers in the room who are willing to come and take care of any misunderstandings that you may have. If you are a virtual student, you have slightly different options. If at any time you need help or don't think you're understanding, you may call the school office at 502 6400 and ask to be connected to your teacher's room. Tell the school secretary your name, that you are a virtual student. Give the name of your teacher and which period. If you are not calling during the correct period, you may not be connected to the room. Also, you can send a text through Remind and work on something else until your teacher answers, or you can send an email and work on something else until your teacher answers. Sometimes with Remind texts and emails, it will take us a while to get back to you if we are dealing with a lot of questions with in-person students, but we will answer your question. If you can get through on the phone line, that might be a little bit faster. If it's a Tuesday or Thursday, you could probably also get straight on to Zoom. So I'm going to add that as another option that you may be able to connect by Zoom if it is a Tuesday or a Thursday. Now, let's get on with the topic. The topic is inequalities. So for these directions, it says to set up an inequality to represent the situation, graph it on a number line, and write it in interval notation. These are the three ways: quality notation, number line notation, and interval notation. These are the three ways we show our answers with inequalities. So we're going to start with something that might be familiar to you, which is speed limit. Usually you see speed limit signs that just have the top that you can go, but occasionally you will see a speed limit sign that includes the lowest speed that you're supposed to go. The speed limit on part of I-65 is 55 miles per hour. The minimum speed at the same point is 45 miles per hour. Write an inequality to represent that scenario, graph it, and write it in interval notation. You do always want your intervals to go least to greatest. So we're going to set up this entire scenario thinking about least to greatest. The least speed that you can go is 45. You should travel greater than or equal to 45. And at the same time, you should travel less than or equal to 55. You can take this scenario and you can actually write it as x in between the two numbers, 45 and 55. Between x and 45, the inequality was open to the x, so I'm going to leave it open to the x. It looks like I turned it around to do that. And between the x and the 55, it was not open to the x, so I'm going to leave it not open to the x. Both of these are ways that you can write a scenario that includes numbers in between two parameters. That is the equality. Now we're going to graph it. Graph it simply means to put it on a number line. So I at least need my number 45 and my number 55 on my number line. Between x and 45, I can go 45, so I'm going to put a colored in dot. And it's open to x, which means I go to the right. And between x and 55, I will also put a colored in dot on 55. This is not open to x, so I'm going to be going to the left. These arrows are going to come together, and I will color in this whole section between 45 and 55. Represent these are the speeds that I may go on the interstate. I could go 50, which is in between those. I could go 51, 52, 53, but these are my limits. For interval notation, I look at the kind of dots that I have. have a closed dot, or I have an equal sign for my minimum. So I'm going to put a squared bracket with my 45. For my maximum speed, I also have an equal sign or a colored in dot, so that will also get a squared bracket. Now, this is slightly different because I have two numbers at the end of my interval instead of an arrow pointing to infinity. So this is slightly different. My next step is to write an inequality to represent when you would be given a ticket. So you would be given a ticket, and we're going to do our least to greatest again. If you are going less than 45, you can actually get a ticket if there is a posted minimum, or you can get a ticket if you are going greater than 55. This cannot be combined like this was in between two numbers because this is an or scenario. You're going to go less than 45 or greater than 55. So I'm still going to have those two numbers on my number line. But for 45, I do not color in the circle. And it is not open to X, so my arrow will go to the left. And for the 55, I'm going to also have an open circle. And it is open to the X, so I'm going to go to the right. Now, this number line has two parts, so my interval will have two parts. It is pointing to negative infinity over here, and then it comes up to 45. Infinities always get regular parentheses, and open circles get regular parentheses. The other part of my interval is from 55 to infinity. The arrow is pointing to the right. These also get regular parentheses. To show that these both are part of the same scenario, we put what is a flat U, which means union. The union of these two is the answer to the question. I'm going to take the scenario and I'm going to put it into a table. And I would really like for you guys to spend some time making a neat table and putting this all in the table so that you can find this table in your notes and look back at it as you need it. So I'm going to still use this table, and the speed limit is going to be my example. And this is going to be legal speeds for the end and speeding tickets for the or, just like we just did. So for an and situation, you can write the word and in the middle, like we did. And you can also put your X between the least and the greatest numbers. These are both ways that you will see and given to you as we go through these compound inequalities, which means more than one. For the or, you could have something like this where you could get the speeding ticket. You put the word or, and you will see your or scenarios with the word or. They will have the word or. Your and scenarios may have the word and, or it may be written as one long inequality with your variable in the middle. For number line notation for an and scenario, and I'm not going to put the numbers on here. I'm just going to show that an and scenario will have a section that is colored in between, and an or scenario will have a section that is going out to the left and out to the right. These may be open or closed depending on the scenario. So for our speeding scenario, we have the correct ones, but depending on what story you might be reading next, you may have one open and one closed, or both open, both closed. But an and scenario should be coming together, and an or scenario should be going apart. For interval notation, you have one interval, So the one interval that we had was from 45 to 55. Those were the speeds that you could go. And for the or, you will have two parts to your interval. One part is the left side of the number line, and the other part is the right side of the number line, joined by that flat U, which means a union. Now, there will be some exceptions, and I hope that you have this chart completely drawn with these titles on the side so that those can make sense. And as we work through this video today, we're going to come back and fill in this chart of exceptions. I do want to point out that you may have brackets or parentheses depending on the scenario. So what I have in this table is not always going to be true. You will not always have two brackets here or just parentheses here. You could have a bracket here. You could have parentheses here. It just depends on the scenario at the time. So we're going to come back as we work through today and fill in these two exceptions. So here's another example, and this is a true story, guys. To get hired as a Disney princess at a Disney theme park, you also have to fit Disney's height and size requirements. Most princesses have to measure between 5 feet 4 inches and 5 feet 7 inches to preserve character integrity. The directions write an inequality to represent the acceptable height for a Disney princess. Okay, a Disney princess can be more than 5 foot 4 inches, and at the same time she has to be less than or equal to 5 feet 7 inches. Remember, I could take, since this is an and scenario, I could put X in the middle of 5 foot 4 and 5 foot 7. And I keep my inequalities doing the same thing to X. So this is open to X. I'm going to put it open to X with 5 foot 4. And it is not open to X with 5 foot 7. So this is what I could write for my inequality notation. This is an inequality. For a number line, I would need to have 5 foot 4 inches. I'm going to go ahead and fill in 5 foot 5 inches, 5 foot 6 inches, 5 foot 7 inches. Can you be 5 foot 4? Yes. So colored in dot. Can you be 5 foot 7? Yes. So colored in dot. You can be anything in between there. So you could test a number. You could say 5 foot 5. Is 5 foot 5 greater than 5 foot 4 and less than 5 foot 7? Yes, it qualifies. This is my number line. Or sometimes you will see the directions that say graph. If you graph it, you're just putting it on the number line. And then lastly, your interval notation. Since I have a closed dot, that is a bracket at 5 foot 4 inches. And I have another closed dot, so that is a bracket at 5 foot 7 inches. This is your interval notation. So inequality notation, number line notation, and interval notation are the three ways that you need to be able to show your answer, because when you take your test, you may have 4 choices that are intervals. You may have 4 choices that are number lines. You may have 4 choices that are inequalities. So you need to know that these 3 are connected. Here's another real world situation, possibly for the winter time. The temperature varied from -2 degrees to -4 degrees. So here's my -2. Here's my -4. It can be -2 degrees. It can be -4 degrees. And according to this, from -2 to -4, we're talking about the temperatures in between. So because it had a number line, I went ahead and made my number line first. We can still make our inequality notation. We're going to do least to greatest. So -4, -2, and I'm going to put x between them. X is greater than -4, so that's open to the x, but it's less than -2. This is my inequality. The third way is to make my interval from -4 to -2. And once again, I used closed dots, so I use squared off parentheses, otherwise known as brackets. Okay, this is not a real world situation, but this is another good practice. X is between 5 and 9. You could change this to say X is greater than 5. And the reason I say greater than, because it was open to X over here. And X is less than 9. So both of these mean the same thing. These are both and scenarios. Greater than 5. Well, 5 is between 4 and 6. So I'm going to go right here at 5. And I'm actually going to leave it open because I do not have an equal sign under here. And I'm going to go over to where 9 is. I'm also going to leave that open because I do not have an equal sign. Since it is an and scenario, I'm going to take the numbers in between. But this time when I make my interval, I'm going to have parentheses from 5 to 9. And I have regular parentheses because I have open circles. Here's another example. X is less than 4 and is at least -9. So this is an and scenario, so I'm expecting my number line to come in together. So let me write this out. X is less than 4. X is less than 4. And at least 9. We spoke about this word before. At least does not mean less. At least means I want more. So I'm going to say greater than or equal to -9. Now I've written this in the order that it came in the story, but if I want to put this and combination, I'm going to do least to greatest. -9 is less and 4 is greater. And then I will put my x in between. Between x and -9, it's open to x. Between x and 4, it's not open to x. Now, you won't be asked to change these on the test, but you need to be aware of both ways that it can be presented because it can be presented either way on the test. To put this on the number line, I'm going to go to the -9, and I will be coloring in that circle. And I'm going to go to the +4. I will not be coloring it in. There's not an equal sign. This is going to be the space in between. And I can check. Say if I check 0. Is that less than 4? Yes. Is it more than or at least -9? More than -9? Yes. So this is the correct area in between. When I get ready to do this as an interval, I like to look from the number line. So I might suggest when you take your test, even if they don't give you a number line, to make a number line. It's super easy to go to the interval. The left side will have squared off or brackets, and the right side will have parentheses. The numbers that are in there are -9 and 4. I do not have arrows coming out of this going to infinity. It is just between those two numbers. So those are all and scenarios. Now I'm going to show you an or number line. On this number line, x is greater than -2. So here's my -2. I'm putting an open circle because it doesn't have an equal, and it's open to the x, which means I'm going to go to the right. And then I have or x is less than -7. Here's where -7 is. It's being left open because I do not have an equal sign, and it's not open to the x, which means I'm going to go to the left. And in this one, I actually do have arrows pointing away to negative infinity and positive infinity. So if I make this into an interval, I'm going to have two parts, just like we put on our table, our chart at the beginning of our notes. This is pointing to negative infinity, and it's coming up to -7. Infinity always gets regular parentheses, and open circles get regular parentheses. Then it starts over again at -2, and it points to positive infinity, open circle, parentheses, infinity, parentheses. And I put that flat U in there to say that these are both parts of the same answer from the same question. So remember, when you do an or, then you should have arrows that are going away from each other. They should not come in, they should go away from each other. Now, here's a real life scenario. A normal diastolic blood pressure range for a high school student is 60 to 80. Represent an inequality for someone that would not be in normal range. Not in a normal range would be less than 60 or greater than 80. Those are not normal. To put those on a number line without spending too much time, I'm just going to put the two numbers 60 and 80. Open, because I do not have equal signs. And then I use my number line to make my interval notation. This is pointing to negative infinity, stopping at 60. Infinities always get parentheses. Open circles get parentheses. I'm going to make it part of the same answer with 80 to infinity. Now, obviously, you're not going to negative infinity with your blood pressure. You might go to 0, which would be very bad. Or if it went too high, that would also be very bad. You're not actually going to reach infinity with your blood pressure range. So what about this one? This one says all real numbers greater than 7. Here's my clue word, or less than 5. Since this says or, I'm expecting a number line that goes out to the sides. Maybe I've got an open circle, maybe I've got closed, but I'm expecting this since it says or. So let's try that. Greater than 7. X is greater than 7 or less than 5. X is less than 5. So I'm going to go find 7 right here. Open circle because I didn't have an equal. It doesn't say or equal to. And open to the 7 means I'm going to go to the right. And then less than 5. So I'm going to find my number 5. Less than is going to be coming this way. And I did get my expected picture for an or situation. So I can test the 6 in here. It's not colored in, so it shouldn't work. Is it greater than 7? No. Is it less than 5? No. So I shouldn't color that in, and I didn't. I colored in away. Let's try the 4. Is it greater than 7? No. Is it less than 5? Yes. And since it says or, it only has to fit one of those, and it fits one of those. From the number line, I can see that it is pointing to negative infinity, coming up to 5. And it's starting at 7 again and going up to infinity. Everything has regular parentheses here because it's either infinity or an open circle. Okay, x is greater than or equal to 2 and less than 3. So for and, I'm expecting a picture that has a section colored in between two dots. Now, those dots could be colored in or open, but mostly what I'm looking for in this situation is I'm hoping that it's going to be coming together. So let me write that out. X is greater than or equal to 2. X is greater than or equal to 2 and less than -3. X is less than -3. Now I wrote the 2 first and the -3 is second, but when I put things on a number line, the lowest number is the left is least. Then I'm going to come up -2, -1, 0, 1, 2. Here's my number 2. Greater than or equal to 2 means I'm going to color in my dot, and it is open to X, so I'm going to go this way. And then less than -3, that would be going this way. Now, this is the picture that you get for or. This is what I'm expecting right here. I'm expecting and, where it comes together in the middle, but I got this. So let me just pick a number 0 and make sure that I wasn't supposed to color in here. So is 0 greater than or equal to 2? No. Is it less than -3? No. So I did go in the right direction, which means and can't be true for any numbers. You can't have a number that's greater than 2 and less than -3. So I'm not even going to write an interval here. I put that there is no solution. There is no solution when you're supposed to get a number line that comes together, but you get a number line that comes apart. So we're going to go back to our table at the beginning of our notes, and we're going to fill in the first exception. The first exception, when you are supposed to get and, but you get something like this. Then you will write the words no solution. You must write the words no solution and make sure your teacher understands that this picture is not the right picture for and you cannot find a number that is less than one thing and greater than something further apart on the number line. So this is our first exception. And here is one last example. In this example, X is greater than or equal to -3 or less than 2. Since this is an or scenario, we are expecting a picture where the number line separates into two parts, into two different directions, toward -infinity and +infinity. So let me set this up. X is greater than or equal to -3. X is greater than or equal to -3. Or less than 2. X is less than 2. So let's put this on a number line now. -3 is the least, so it's going to go on the left, and 2 is greater, so it goes on the right. At my -3, I will have a closed circle because it says or equal to. And since it's open to X or greater than, I'm going to start heading to the right. For X is less than 2, I will have an open circle. And since it's not open to the X or less than, I'm going to start going to the left. And as you can see, what just happened is I have an and picture, but I have an or scenario. An or scenario should have lines that are going apart, but I've ended up with lines that come together. In this case, instead of saying there's no solution, I could actually let this going from the open circle cross through and continue to the left to -infinity. And the arrow that's coming from the closed dot can cross through and continue to the right to +infinity. Here's why. You only have to fit one of these inequalities for an or scenario. So everything on this number line is either less than -2, +2, or greater than or equal to -3. That covers everything on the number line from -infinity to +infinity. If I made an interval for that, the interval would go from -infinity to +infinity, or you may write the words all real numbers. Now, we're going to go back to our table from our notes earlier. And mine is already filled in because my internet went out and I didn't know that it wasn't recording when I made this earlier. So it looks like an and, but it was supposed to be an or, which means it really does go to negative infinity and positive infinity. The answer is all real numbers when you get the unexpected exception for or. By the way, while you're here, if you explicitly copied my notes, I had a 55 here, and this should be a 45.